Good morning to all. Myself Lingeshwari, working as an assistant professor in EC department, P.S.R. Engineering College. Today we are going to see about modeling of physical system in control system. So actually control system is a collection of physical objects which is connected together. So this system having the input output relationship, that is the physical components having the input output relationship which is governed by the differential equation. So actually this differential equation, before going to write the differential equation, we must find out the transfer function of the particular system. It may be the mechanical system or electrical system. So before that, the transfer function is nothing but the ratio of the Laplace transform of output to the Laplace transform of input with zero initial condition. So we have to consider the zero initial condition for while taking the Laplace transform. So now we are going to see about the modeling of the system. Normally it consists of many types. Now we are going to concentrate on only one system, that is mechanical system. So the mechanical system itself consists of mechanical translational and mechanical rotational. So now I am going to take mechanical translational system. So mechanical translational system, it is governed by basic elements, that is the three basic elements are mass, spring and dashpot. So these three elements play a vital role while designing the translational system or to find out the transfer function of the particular system. So before going to solve the mechanical translation system, we must know the force balance equation for these three elements. So mass, spring and dashpot, where mass is the weight of the body and spring is the elastic deformation of the body, and dashpot is which is in a viscous fluid, it is a piston moving in the particular unit. Okay. So the force balance equation for mass is the mass we have, if we apply the force, that is the input to the system F, it will be replaced or displaced by some changes. It is considered as X and it is connected to one reference plane. So this force balance equation can be written by Newton's second law. So the Newton's law, second law states that the forces acting on the body is fully zero. So F suffix m, which is proportional to the acceleration of the body. So Fm is proportional to d squared x divided by dt squared, where x is the displacement of the mass, that is weight of the body, and we are going to replace this proportionality constant as the mass. So the equation becomes Fm is equal to m into d squared x divided by dt square. So this is the force balance equation for mass. Similarly for spring, it is denoted as K, and if we are applying the force F, and this is also having some displacement, it is considered as X. So by using Newton's second law, the Fk, that is the opposing force for the spring, is proportional to the displacement. So to remove the proportionality constant, here also we have K into X. Similarly for dashpot, the another element of the mechanical translation system is dashpot. It is denoted as B, and if you are applying the force to this element also, it also having some displacement, that is considered as X. So the force balance equation for dashpot is written as Fb, which is proportional to the velocity of the body, dx by dt. So, to remove here also we are going to remove the proportionality constant as B. So, by using these three elements, we are going to find out the transfer function or gain of the mechanical translation system. So, by using these three elements, we will see one example problem. So, this is the mechanical translational system. So, now we are going to find out the transfer function for this mechanical translation system. So, here if you see the diagram, that is the mechanical system, the input is applied at this mass m2, that is f of t. So, there is no force applied for m1. So, first we have to draw the free body diagram for m1 by writing the equation f m1 plus free body diagram for m1, that is the first mass. Here there is no forces applied for this mass. So, there are all the forces are opposing forces. So, F m1 and it is connected with the dash pot, it is denoted as B1, F B1, and it is another one dash pot is connected between m1 and m2, that is FB, and also the spring is connected as K1 and K. So, FK1, F2. So, these are all the opposing forces for this mass m1 and the displacement is x1. So, there is no forces applied for this m1. So, by using Newton's second law, we have to write as Fm1 plus Fb1 plus Fb plus Fk1 plus Fk, this is equal to 0. So, already I told about how to write the force balance equation for these three elements. So, considering that, we have to write that, and going to write the equation directly as m1, here the displacement is x1. So, d squared x1 by dt squared plus b1 dash for dx1 by dt plus b, that is this dash part is connected between m1 and m2. So, d by dt of x1 minus x. Similarly, k1 into x1, and here also the spring k is connected between m1 and m2. So, the equation becomes k into x1 minus x, this is equal to 0. So, now we are going to take the Laplace transform for this equation with 0 initial condition. So, after taking this Laplace transform, this equation becomes m1 s square x1 of s plus b1 into s into x1 of s plus b into s into x1 of s minus x of s plus k1 into x1 of s plus k into x1 of s minus x of s, this is equal to 0. So, if you solve this equation, we will get x1 of s is equal to bs plus k divided by m1 s square plus b1s plus bs plus k1 plus k into x of s. So, you can consider this equation as 1 and this is 2. Okay. So, while drawing the free body diagram for M1, we get like this, x1 of s is equal to this one. Similarly, we are going to draw the free body diagram for the mass M2. Free body diagram for mass M2. The only difference between the mass M1 and M2 is the force is applied at M2. So, you are going to draw the free body diagram by putting F of t here, that is the applied force. So, the opposing forces are Fm2, Fb2, Fb and Fk. So, by using Newton's second law again, we are going to write the equation, that is opposing forces, which is equal to the applied force. So, Fm2 plus Fb2 plus Fb plus Fk, this is equal to F of t. Again, we are going to write the force balance equation for all the three elements for mechanical translation system. So, now the equation becomes m2 d square and displacement is x. So, d squared x divided by dt square b2 into dx by dt b into d by dt of x minus x1, because we are choosing the force which is acting on this m2. So, this becomes x minus x1 plus k into x minus x1, this is equal to f of t. So, you can consider this as equation 4. Here also we are going to take the Laplace transform with 0 initial condition. If you are taking the Laplace transform, equation becomes m2 s square x of s plus b2 s into x of s plus b into s into x of s minus x1 of s plus k into x of s minus x1 of s. This is equal to f of s. Okay. So, separate the term x of s and x1 of s. If you separate it and after that substitute the equation 2 in the above equation, we get, that is the transfer function of the given mechanical system is x of s by f of s, which is equal to m1 s square plus b1 plus b into s plus k1 by k divided by m2 s square plus b2 plus b into s plus k into m1 s square plus b1 plus b into s plus k1 plus k. So, finally, we get the transfer function as x of s divided by f of s, which is, if you substitute all this equation, we will get like this, the transfer function as x of s by f of s. Thank you.